expressions and equations and sort of that stuff. And I did a little work in my other book, my math book, not this book, but I don't fully understand it. So,
Okay. Well, that's fair. That's fair enough. So we'll do the recipe here where I show you one like it, and then you have to do one on your own. Okay.
okay.
I mean, that's the only way I can sort of reasonably help you here. So this is like number one. And we got something like this. We got we'll just say x squared minus 9 over x minus 4, and x equals -3. Now, very important, when you substitute in, you have to like almost assume the variables are in parentheses like this.
Down.
Okay. And that's really important, because when you put this number in for x, you're really putting it in to the parentheses.
Mhm.
So it looks like this: -3 squared minus 9, -3 minus 4. Okay. Now, the main reason you put it in parentheses is that like there's something to do to it. There's an operation, and you don't want to like exclude the sign. So in this case, the operation is the square here. What is -3 squared?
Oh, -9.
It is not -9. It's -3 times -3.
Okay. -3. So that would cancel, right? Let me
It's,
think. Yeah, so that would
it's positive,
cancel.
+9,
That'd be 9,
positive
yes.
9, +9 minus 9. And then on the bottom here, you have -3 minus 4. All right. So in the top, you have 0. What do you have on the bottom?
We have 0. That would be, oh,
They're both negative, so the answer is negative, and then you add the numbers without the sign.
so 7.
So 7, -7.
Yes.
Now,
All right.
0 divided by any number except 0 is 0.
0. Okay.
So what that means is, okay, I got nothing to share, 7 people to share with, they're not getting anything. Okay.
Mhm.
All right, so that is sufficient for you to be able to do a problem like number one. I'd like you to try that now. Happy to scroll up if I need to, but please work that out. Let me know if you have any questions along the
Okay.
way.
Yeah. Okay, there you go.
Do you have an answer for me?
Mm-hmm.
Okay,
Okay,
what do you got?
so 0 over -9,
Okay, and what does that become?
that would become 0.
Yes.
That was it. So let's put that
So there's
here.
your answer. Good.
Equals 0. Okay.
Now, number two is really similar, meaning that you just substitute the numbers in. Like,
Mhm.
see how there's a y in the top? You can really treat it as 6 times y squared, x squared minus y squared. You've got both x and y. Do you
Mhm.
want to try this one now on
Mhm.
your own?
Okay. Mhm. Put that. And then 8 minus 4. That might becomes. I think I did something wrong here.
Okay.
So,
Let me write this and you tell me if you have something similar.
okay,
Do you have something like this?
have that.
Okay. You gotta square everything first.
Mhm.
What is -2 squared?
Negative, that would be 4.
So we have 6 times 4. About
Okay.
4 squared on the bottom.
8.
Nope. Square
No.
means you're multiplying it by itself.
Oh, okay, so that would be not 8. 16 and then 2.
Minus 4, because you just said
Yeah,
-2 squared is 4. It has nothing to do with the subtraction operator. Okay, so try it from here.
so that's what I did wrong. Okay. So 6, 4, and 16. Okay. That would be 6 times 4, 24. And then 16 minus 4 would be 12. Yeah.
Okay.
24 would be 12. And then that would equal 1/2? No.
What number is on top? What number is on bottom?
24 is on top, 12 is on the bottom.
Okay, so it is not 1/2.
Hmm.
24 things, 12 people. How many things does each person get?
2. So that'd be 2.
Yep. Okay.
Okay.
Any questions on that?
No,
All right.
2.
So um, now let's go to number 3. Now, unfortunately, these are where it gets very hard for me to give you one like it. So we'll have to kind of work through these together here for a bit.
Mhm.
All right. It says to find the least common denominator for each group of rational expressions. That means you don't care about what's in the top. In fact, you should either literally cross it out or figuratively, like ignore it. Somehow you gotta, you gotta do that. Now, you're looking at a squared b and ab squared, okay? So you have to look at them one letter at a time. So you're looking at the a squared and the a. You see that?
Yeah, I did.
And your least common denominator is the larger exponent. So which is the larger exponent?
A squared.
So a squared, okay? Then you look at the b. And guess what? You do the same thing. You look for the larger exponent. Which is the larger exponent?
B squared.
B squared. There's your least common denominator.
B squared. Okay.
So since I can't give you one like this, I want you to look over these notes here and tell me, try to echo back what we did here. I want you to explain to me the process as best you can.
Okay. So we're gonna do number 4.
No, I'm asking you to tell me what we did in number 3. Like, just tell me back what we did.
Oh,
So I can gauge your understanding.
we found the least common denominator. We just looked at each how variable, and we looked at each exponents. I think that's what they're called. Yeah.
Okay, so let me ask you some questions. Why did I cross out the stuff?
Because they're unnecessary.
Exactly. Very important. Let's just ignore that. We're looking at the least common denominator, and we're only looking at the bottom.
Mhm.
Why did I highlight the a squared and the a?
We're focusing on that, on the
Yes.
A's.
Yes. Okay, good. All right.
Whoops.
All right. So we will now look at number 4.
Okay.
Let me know when you're ready for this one.
Mhm. Just cross those out. Okay, I'm
So
ready.
all right, so we're just looking at the x minus 2 and the x squared minus 4. Now on the right here, you have to factor this out. Okay, this one's different than the previous one. Do you remember what type of factoring this is?
This LCD
No, forget about the LCD. Just
mhm,
look at the x squared minus 4. What kind of factoring is that?
factoring. I wouldn't know the term.
It's called difference of squares.
Different squares. Okay, let me write that down.
Have we talked about that?
I believe we did.
Yes. Yes, we have. Okay. So I'm going to give you an example rather than just doing this one for you. I'm going to give you an example down here of difference. Let's say it's x squared minus 25. Okay. This becomes x minus 5, x plus 5.
Yeah, let me write that down. Square 25. And then analyze it. Okay.
Right. So now let's go back to your problem. Try factoring this using the same thing.
Mhm. So this would be x plus 2 and then x minus 2.
Yes. X minus 2, x plus 2. The order
Two.
does not matter.
Okay. All right. And then
All
what
right. Now
about the other one?
we're going to get to that. We're going to get to that. All right. So here's the other one. When you look at, I'm going to highlight everything here. what is the same, what is different?
The x minus 2 and x minus 2 are the
Okay, good,
same.
good. Now that's really important because what's the same has to come down. You have to have an x minus 2. Okay.
Mhm.
And now it's kind of like, do you have any brothers and sisters?
No.
No. Okay. Okay. So then just ask because it's an analogy. But like, so let's say you and your friend, you got an x minus 2 and he's got an x minus 2, but he's got an x plus 2. So what are
Mhm.
you missing?
An x plus 2.
An x plus 2. That is your LCD. So you have to ask the question, what is the same? What is different? How do I make these look the same? We do this when we're, if you take something apart and you get a new thing and you're
Mhm.
like, it's broke or something, it's like, well, what's missing? What's not, what's the same? What's different? It's a really common question. We do this all the time. You come home and, you know, the there's a new couch or something, and you're like, oh, it's different, but
Yeah.
it's like we do this naturally. So it's really a very common thing to do. That is your answer.
Mhm. Okay, let's put it here. Okay.
Okay, so I want you again here to just kind of echo back what we did in the problem, if you don't
Okay.
mind.
So we broke apart x squared minus 4, and then we found, I guess, two, how would you call these?
So don't worry about the words. Just kind of keep
Okay.
keep going.
And then we found two are what is similar, what is the same, and then we brought down two that were different, and that was the answer. Is that the
Yes.
best explanation for me?
Right. So we're gonna draw a little bit of a parallel to the Bible here. Jesus walked the earth 33 years. He said things to the disciples, and they even repeated some of them. He'd say, like, who am I? And then they'd say, you are God, right? They would say
Mhm.
something, but they didn't really like understand it. They didn't believe it. And Matt, we're not making, there's no perfect analogy here. But when I have you echo something, even if you don't fully understand it, when you just throw it out there, and later on, maybe you will. It's like the disciples realize later on, they're like, oh yeah, he was the son of man, son of God. And you're
Yeah.
like, sometimes later on, you get like, oh yeah, I get it.
Hmm.
Let's look at number 5 here. All right. So again, you just cross out that top. Like, I don't even care.
Hmm.
All right. Now you typically go to the more complicated side. Which one is more complicated? The one on the left or the one on the right?
The one on the left.
On the left. So this is another type of factoring. So I'll just ask here, do you see any type of factoring in this? It is not the same as the last one.
Factoring is r squared. I don't think I really understand the factoring, like what it really means.
Okay, okay, that's okay. So let me give you an example down here. Let's say it's x squared minus 8x. You'd see that these both have an x in them. An x squared has an x in it and an 8x has an x in it.
Hmm.
Okay, so you're basically dividing both of these by x.
Okay. I should do that one. Okay. X. Um, x squared would be x
Okay, minus
minus x
minus 8.
minus h, because they cancel. Okay.
Okay, so let's have you try one over here. Let's say it's y squared minus 6y. I want you to try factoring this for me, please.
Okay. So divided by y, by y, by y minus 6. Okay, the answer would be y, y, and then in parentheses, y minus 6.
Exactly.
There we go.
All right. Very good. Now, let's go back up to your problem. I need you to factor this one.
It's minus like r, 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 r minus 4, r, and then r minus 4.
That's right. R and then R minus 4.
Minus 4.
Okay, I'm gonna ask the same question we did last problem. What's the same? What's different? Now it has to be exactly the same. Exactly. Okay.
Mhm.
It's like even if two shirts are the same at their different sizes, they are not the same. They have to be exactly the same. If you see anything
Yes.
that's the same,
No.
no. So your LCD, you got to grab everything. R, R minus 4, R plus 4. You have to grab everything.
Mhm. Okay. So the okay. Sings. All right. I think that would be it. So I don't really see.
Yeah, that's it. That's it for that one.
Okay.
6 is just a more complicated version of the same thing.
Mhm.
All right.
Right, that's minus.
Let me know when you're ready.
Mhm.
Okay. So first thing I'm noticing here is that there's 3 things this time, whereas the
Oh
previous
yeah.
problems had 2. So it's now not just you and your friend, it's you and your friend and your other friend,
Yeah.
right? Like there's a group.
Uh-huh.
And you know, it's have you ever tried to get together with a group of people? And it's easy when there's 2 people. It's like, okay, when can you meet? I'm free after 6. Oh, I'm free after 7. All right, let's meet at 7. You add a third
Mhm.
person. Oh, I'm free after 6. Oh, I got to be back by 9. I'm free after 5. I can stay out till 10. Oh, I'm not free at all.
Yeah.
Right? Like it's tremendously frustrating. So when you make an LCD, it's basically like figuring out how to get everything arranged so that everyone gets what they want, basically.
That's true. Or some don't even want to come.
Yeah, right. And we're gonna see that here. We're like in this case, like this one's, well, I shouldn't say it. One of these is just off on its own. Now we do have to factor this, okay? And this is yet another type of factoring. So factoring means to expand. I probably should have
Mhm.
said that earlier, but factoring means to expand.
Okay.
I'm going to factor this for us just because we don't have an infinite amount of time to do that.
True.
Okay.
All right.
So this is like Thanksgiving dinner, and you want to get a little bit of everything on your plate.
Mm-hmm.
You know, even if you don't think you're going to like it, you want to get a little bit of something on your plate, which means you got to get one of everything. But you don't go back. Like if you grab the cranberry sauce, you don't grab the cranberry sauce again.
Yeah.
Or if you get the stuffing, you're done with the stuffing. And if you get the green beans, you just get the green beans. You don't go and get the other green beans. And I know there's exceptions to that, right? Like if you're going to a potluck, and it's like, you know, your aunt's got her green beans and your grandma's got her green beans. You don't want to, you don't want to
Yeah.
upset them, so you get some of both. But like for purposes, you're going to
True.
grab this. So I want you to try just telling me what the LCD is here. You're just
Okay.
picking, grabbing. You're not doing anything. Um,
I think it would be W plus 5 and then W minus 2 and then W plus 1.
You got it. That is it.
Circle that, and boom.
Okay. Let me
And
know.
Okay.
Now, my question is it better if we get done more of this? Or is it better if we just go in order? Like, and for the reason I'm asking is like 11 through 14 go pretty quickly, but
Okay.
7 through 10 do not. And like, if it would help you to get more of this done, we could do that.
I would say, yeah, get more done.
Okay,
I'll do
got
this,
it.
get more done.
All right, so we're gonna come back to 7, 8, 9 at some point, but we want to do the next ones first, and they're somewhat related to what we were just doing. All right, determine the values that x cannot equal for each rational expression. So I always jokingly say the first math commandment is thou shall not divide by 0.
Mhm.
Okay, which means that again, you don't care about the top. You care about
Bottom.
the bottom. In fact, you want to know where does the bottom equal 0?
Okay.
Because when the bottom is 0, that's bad. That's when you're dividing by 0.
Mhm.
So can you solve this equation for us, please?
So would I have to divide?
Nope.
Like,
You're
oh,
undoing addition and subtraction.
undoing. So I guess I would subtract 2 and then subtract by 0, 2. And then x would equal 0 minus 2. Never thought what that would equal. 0 minus 2. -2. X equals -2.
Good, good. Now, this is the value that x cannot equal. So while we solved it, setting it equal, x cannot equal -2.
-2.
That's what we're saying. That's what we're showing here as being
It's not a lot to
the
equal.
the excluded. Yeah, the excluded value.
There. 12.
Is that okay?
Mm-hmm.
All right. So just like we did here, I want you to talk me through what we just did. Tell me what we did from start to finish here on this problem before we go on to 12.
We took x plus 2 and then we put equals 0. Then we subtracted both sides, left and right. And then 0 minus 2 equals -2.
Okay, why did I cross out the top?
It's irrelevant.
That's right. And why did I change it to not equal here instead of equal?
Because x cannot equal -2.
That's
So
right.
you'd be
Okay,
dividing by 0.
very good. So the next problem is the same recipe, same steps. Okay, you actually, again, you ignore the top. You just look at the bottom.
Okay.
In fact, you set it equal to 0, just like we did in the previous problem. Now I want you to look back at problem 5, and I want you to factor this on the left here. This is very similar to what we did in 5.
Okay. This would be x squared would be x minus 5. Look here. I think I have a note card. Here we go.
Let's look back at what you did in number 5. It's really similar. I mean, I'll scroll up if you want as well, but
I have a note. Okay, so this would be x minus 5 and then x plus 5.
no.
No.
Look at number
of the no cards. So I'm trying to.
Look at number 5.
Okay.
Here's number
Fine.
5.
Okay. So this would
You should see
be.
one that's really similar to this. We even did some examples down here.
Would be x, and then in parentheses x plus 5, and then
Yes. Well, look at the sign. What's the sign in here?
minus subtraction. Okay, so this would be subtract 5, and then that's it.
Okay, now that's the start of this one. This one's a little bit different. Now, in this one, you set each of these equal to 0.
0, 0. Okay.
Okay. So
We would need
now
to.
x cannot be 0, but now we have to solve the other one on the right here, just like we did in the previous problem. What do you do to
Mhm.
solve this one?
We would add 5 to both sides.
Right.
Plus 5. X equals 5.
Okay. Now, what's the last little piece? Because we don't write x equals 0, x equals 5. What do we write instead?
Oh, that's a good one. X squared?
Nope. Again, like,
No.
gosh, you got to go back. What did we write here? We didn't write x equals -2. What did we write in the previous one?
X does not equal -2.
Okay, so what are you going to write here? Are you going to write x equals 0?
No, X does not equal 0.
X does not equal 0. And what else does x not equal?
5.
Or cannot equal 5, right? Cannot or
Mhm.
does not or is not, all of those. I mean, I don't know if they're all literal language the same.
There's, so that would be not, okay. Okay. So then 13, are we gonna go over the,
Yeah, we'll do 13 here.
oh, there's my note
Which
card.
do I set equal to 0 in 13? What do I set equal to 0 in 13?
4x minus 0. I mean, minus
-9.
9.
Yes, you at the top completely gone. And
So now, oh, X, okay, there.
okay, now this is a 2-step equation. So you first undo addition and subtraction,
Mm-hmm.
and then undo multiplication and division.
Mm-hmm. Okay, so then we would plus 9 to both sides. And then x, 4x equals 9, which would, then we would have to have x by itself. And
So
that
how do
would
you undo this
be,
4 in front?
it would be divide by 4.
Divide by 4.
Divide by 4.
So x equals 9 divided by
4.
4. Is that what we write up here? Is that the answer?
Ah, I would say no. I have a feeling.
Well,
Uh,
what did we do in the previous problem?
We wrote everything that does not equal. We put a
That's
slash.
right. That's right. Because it cannot equal, does not equal, is not equal to. So tell me what to write up here in the blank.
It would be x does not equal 9 over 4.
That's right.
It's not equal 9 over 4. Right
Because
here.
it's a big difference. It's a big difference to when, when someone says you can do this or nope, you cannot do this. It's a big difference. Go right, go left.
Mhm. All right, new flashcard. I'm running out of flashcards. Okay.
So we're gonna go to 14
Or the
here.
top half.
What do we set equal to 0?
We set x squared minus 4x plus 4.
That's right. You ignore the top. You say top doesn't matter, just the bottom. All right. Now, in terms of factoring this, I'm going to help here because it just won't take forever. But this is called a perfect square trinomial. At least put that in the notes.
Hmm.
Perfect square trinomial. This is a type of factoring here. So it ends up being x minus 2 equals 0. And it is correct. They are both the same in this one.
Whoa, okay. Write all that down.
Now, just like the previous problem, you have to set them equal to 0. You have to set each one equal to 0, like that.
Hmm. Okay. So I have that down.
Okay, go ahead and solve those for me, please.
X equal plus 2 both sides. X equals 2. And then same thing with this one. X equals 2.
They're the
Okay.
same.
Yeah,
They're
they're
the
the
same,
same.
right? So what
Hmm.
that means is you're duplicating. Okay. I mean, I don't know how frustrated you get, but when someone tells me the same thing twice, I get pretty frustrated. Or if the signs, two signs say the same thing,
Yeah.
but you only need to include one of them. Like you don't need to say them both. You just say that X what goes up here in the blank.
Would be X is not equal to,
Two. Yeah,
that's it.
that's it.
It's not equal to. Oh, right on the window. Okay. Yeah,
All
I'll
right,
just
now
put
we're going to
them
go
this way.
back and do 7. 7's pretty fast. We'll do like 7 and 8, and then we'll also maybe get some of the ones in the bottom.
Mhm.
Sorry, the next grouping, but we're going to do the kind of the easier ones here.
Okay.
All right, so take a look at this problem here.
Mhm.
The instructions say to perform the indicated operation on the rational expressions. What is the resulting expression in factored form? Okay, so first of all, we're going to combine these. Okay, and the only way you can combine two fractions is if they have the same denominator. Do these have the same denominator?
Yes, the
They do,
bottom half.
which means you keep the bottom, but then you combine the top.
At the top, okay.
All right, so on the top, I want you to get this written down, but on the top, can you do anything? Can you combine like terms?
You combine like terms.
Yes.
I would say
Or anything that you
yes.
can, okay, you can. What can you combine?
Hold up. What? Okay. What can you combine? 5x minus 3x. I guess you can combine those since they both have x.
Okay, what does that become?
So would this be a subtraction since it's a negative 3 or
Yeah, it's 5x minus 3x, 5 minus 3.
oh, whoops. 5. Where do I give the x here? Here we go. Put x, 5x minus 3. Here's that. And that would be think I did something wrong. I have that Desmos, the one that you tell me to use.
That's not gonna help you here with the X's. You're
No.
taking 5 minus 3, and you're
It should
putting an X
be
with the answer.
2?
2x.
2x, okay.
Okay, and that is your final answer.
Oh, okay. Yeah. Okay. Now,
Now, very important for me is that you kind of talk me through what we did in this problem. Just tell me as much as you can so that I can gauge your understanding here of what we did.
let's
You don't have
see.
to know why, you just have to sort of say, well, here's what we did.
Mhm. So we took both, I don't know how to call them. We put them on one line, 5x minus 3x. So we combined x plus 1. And then we solved 5x minus 3x. And then we have 2x over x plus 1.
Okay, yeah. So some of the words there, denominator is the right word for the bottom, but you can see I wrote
Mhm.
both. You can just say bottom,
Mhm.
top, bottom. I mean, that's okay.
Mhm.
Like, this is not a class where the words are that kind of critical to where, if you don't,
You're gonna fail.
yeah, it's not like that at all. So keep that in mind. I mean,
Okay.
I'm just looking for some sort of like, okay, yeah, we did this, this, and this, and we got it. All right.
Mhm.
So we're going to look at number 8 next. We will not be looking at 9 and 10. Just trying to maximize your time here.
Mhm.
But question for you, are the bottoms the same?
No.
No, they are not the same, but we can turn the 4 into a 12. How can
Mhm.
we do that? How can we turn 4 into 12? Well, you can multiply by
3.
3. Okay. So if you multiply the top and bottom by the same thing, and that's really what the takeaway needs to be. Multiply the top and the bottom by the same thing. It's no net change.
Mhm.
Okay. No net change, meaning like you haven't really changed it. But let me give you a quick example of that. Whoa, I don't want that. Why did it do that? Okay, let's look at a fraction like 1/2. If you multiply the top and bottom by 3, that is 3 over 6. Is that still 1/2?
I would say it's not 1/2, but it can become 1/2.
Okay, so let's use different words. Is 1/2 of 2? Is 3/2 of 6?
Yes.
Or is 2 double 1? Is 6 double 3? No
Yes.
change, no net change.
Okay.
Okay. And that's what we're saying. Like, net change is like, did it really change in the end, all things considered? No.
Okay.
Okay, so that's why this works here. All right, so now when you multiply this, it becomes 3x over 12 plus 3x plus 5 over 12. Okay,
The same
is that all right?
bottom. More easy. So we have the same bottom.
Now they have the same bottom. This is big. This is important. It's like, okay, they've got the same bottom. So since they have the same bottom, what do we do with the bottom?
I guess we would not
Keep it. Keep it.
keep it. So
Keep the
not combine
bottom.
it.
Keep the bottom.
The 12. Okay.
Okay. And then the top we combine 3x plus 3x plus 5.
Okay.
Okay.
And then combine the top. Okay. So now
So now, are there any like terms in the top?
3x and 3x.
What does that combine to?
6 x squared.
Nope.
Just
Well, in the
6x.
yeah, in the previous problem, right? 5x minus 3x is gonna become 2x squared.
Yeah.
You're just taking away. You're saying, all right, I've got, in this case, you're adding, I've got 3 fish, I've got 3 fish, I have 6 fish.
Mhm.
There's your
12.
final answer.
Okay. Plus 5/12. Okay.
All right, so we unfortunately do not have enough time to go through any more of this. I was going to go through 18 and 19 next. They were kind of the next easiest, but it'd probably take another lesson to get all the way through this. If you know, if anyone's wondering, but